Your project has a finish date. It's probably on the schedule. Maybe it's written over on a whiteboard somewhere in your office, and it looks like a fact because it has a number, it has a month, it has a day. But here's what nobody likes to say out loud. The date that you have on that schedule, on that whiteboard, written down somewhere, it's most likely a guess, a well-intentioned guess, but still a guess. And it's dressed up to look like a commitment. And here's the thing. There's nothing wrong with that. But there is a false precision trap that a lot of PMs can fall victim to, including myself. And today I'm going to show you a tool that gets you out of this. That is the Monte Carlo simulation. You don't need a math degree to run this and interpret the results. And if you're studying for the PMI RMP, this falls into the domain 3 context that you're going to see on your exam. So let's jump into the Monte Carlo. Quick background, if this is your first time here, I'm Russ Parker, PMP, PMI RMP, PMI authorized training partner, and instructor for both the PMP and the PMI RMP. I'm a retired Marine Corps officer, and I run 44 Risk PM LLC and this channel, The Bearded Risk PM. I'm going to give you the honest version of the Monte Carlo today. This isn't going to be some textbook version because I'm not a finance professor. I'm not one of these individuals who are like academic all the way. I want to give you a version that actually assists you as a project manager, shows you what you need to know, not just for an exam, but how you can actually utilize this in your projects. So when it comes to schedules and project schedules, this is the problem that I see when they're getting built. First, you have task A has 10 days. Task B is 8 days. Task 5 is 5 days. Our total ends up being 23 days. Done. Sounds pretty simple, right? But you're probably thinking, okay, yeah, that's how I see them on a lot of different schedules. That's how I see schedules work out. And you're correct when you think about that, because that's a lot. I mean, when I first started off, that's how I was really building out my schedule. This is a task. This is how long it takes. Good to go. Let's keep moving. But the part that everyone skips is that task A doesn't actually take 10 days. It takes somewhere between 7 and 15 days, depending, and this all depends on the vendor, the team, the scope, and just a lot of different variables that can interfere with task A. Task B has its own range. Task C has its own range. When you stack those ranges together, and you do this across 20 different real tasks on your project, the math starts working against you. And this is the concept that we like to call merge bias. The idea is that even if every task hits the most likely estimate, the project almost never finishes on the most likely total date because bad days are going to compound in ways that good days don't add up to it. So the single finish date on your schedule, it is always almost at the optimistic date that your project could finish. Not because you were a bad estimator, but because probability mathematics work against us when we're doing this work. And that's what Monte Carlo tries to make visible for us. So you got to be asking, okay, what is a Monte Carlo simulation? Mostly on a PMP study prep, this might be mentioned that it is a, just a computer program that you possibly use one day. But in the age of AI and all the technology we have, it's not that hard. So the plain language version of what a Monte Carlo simulation is that instead of using one estimate per task, you enter in 3. Your optimistic, most likely, and pessimistic dates. And then from there, you use that triangular distribution formula that I know we've all heard about. And we use that optimistic, most likely, and probability. We use that, we add them together, we divide them by 3. This is a formula that if you're taking the PMP or the RMP, I recommend that you know. It's the one of the few formulas that I recommend to my students that you know for the exam. So the triangular distribution formula looks a little bit like this. And the goal at the end of the day is that we have an expected duration of where we're looking at for our project. Now, the trick is Monte Carlo does not stop at that formula. It runs your project not once, but 5, 10, 15,000 times. And each run that it does is random samples from inside your 3-point estimate range. Sometimes it's closer to optimistic, sometimes it's closer to pessimistic. But each run produces one possible project duration. And after 10,000 runs, you get a distribution, a picture of all futures that your project might land into. And that picture is called a histogram. And if you don't know how to read a histogram, I recommend you learn how to do that. And we're going to practice one in a moment, and I'm going to show you how easy it actually is. Now, here's the output that we get from Monte Carlo. It changes everything. Instead of just getting one date, we get confidence levels that are attached to our dates. And we can call this our confidence range. So when you see P50, this means that 50% of your simulations finish by that date. P80 means 80% finish by that date, and P90 means 90%. So instead of saying June 15th is our date, we can say that we have an 80% chance of finishing by June 20th. In turn, you have information that is less vague, it's more honest, and it is what proactive risk management needs to sound like when you're talking to your stakeholders. So to give you a better idea of what this looks like, I'm going to show you an example of something I built at our website that you can go visit, riskreadypm.com. All right, here we are going to simulate this software rollout. And as you can see, we already have this built out that we're going to run this through 5,000 different simulations. So if you look down at our planning phase, we have an optimistic of 5 days. Most likely it'll take us 8 days, and a pessimistic look that it's going to take us 2 weeks to get this work done. Development, same thing, 12, 18, 30. Testing, 4, 7, 12. And a go live that it should take around 2, 3, or 5 days to get this work done. And you can see within all this work, our highest level of uncertainty sits in that development phase, where instead of where we have the most likely of 18 and a pessimistic of 30. That's a wide range. That matters when it comes to this work. So then from here, we put in our numbers. At the bottom, we click run the simulation. And there we go. We get the histogram that I was talking about, which is quickly just a bar chart that we need to look at. But then down below, we also have the P50, 70, 80, and 90 that we were also talking about. So here we have the P80. There's an 80% chance that we are going to end by day 53 for this project. That is how these numbers work. It's really that simple when it comes to Monte Carlo. But we also, when you look at this histogram, I want you to notice the shape too. If you look, over here, there's a tail. This is a longer shape. It stretches to the right. That's that merge bias I was talking about. The tail on the longer, the tail is longer on that late side than it is on that early side, because the bad days are going to compound over time. Good days cap out. Bad can go on for a while. But then going back to our P80 date, we already know that this date is the 80% solution. That is usually the best date to commit to with your stakeholders. Not because it's the latest, but because it's the most defensible. It has an 80% confidence behind it. So what do you do with all of this information? Monte Carlo, the main goal is to answer 3 questions that every project manager gets asked. First, what is our realistic finish date? Not the optimistic, not the worst case. What our stakeholders want to see is that 70 or 80% solution. That should be your answer. Question 2, where do the buffers actually matter? Monte Carlo shows you which phases drive most variance when we're doing this work. That is where we start building in contingency reserves. That's because everything doesn't spread out equally, and we need to concentrate our work on the high variance phases. And we can see that when we start building this out in real Monte Carlo. And question 3, which risks affect the outcome the most? So if we took this simulation and we took specific risks and we ran it against those different risks that are active, we compare the 2 charts. The gap between them tells us the risk's true impact. This is, in essence, a sensitivity analysis in a different way. So I want you to remember, though, that merge bias. Because when you add up the most likely estimates for our 5 phases, the sum was like 35 days. But our P50 from the simulation was 48 days. So we're going to run higher based off the fact that we want to fill the gap of what is that merge bias. And that is why schedule compression can be so risky. When we're cutting time from one phase, does not always add up linearly to reduce the overall risk of what we're working on. All right, so that's basically what a Monte Carlo simulation is, how it works, and how it looks. Again, go to riskreadypm.com. You can play with this little simulator that I built out for you. But Monte Carlo inside the exam fits within domain 3 risk analysis of the PMI RMP. And that accounts for that domain is 23% of your exam. And task 2, quantitative risk analysis, Monte Carlo is explicitly named under sensitivity analysis. So this is what I want you to know when it comes to this. First, the triangular distribution formula. All right, the opportunity, most likely, pessimistic, divided by 3 gives us our number that we need to look at. 2, what a histogram is. How do you read that chart to understand what your P70 and P80 results are within it? And then 3, Monte Carlo, know when it is the right tool. Large complex projects with multiple uncertain activities, that is when we're going to pull this tool out, especially when our stakeholders need a defensible confidence level that they can use for their projects. And then 4, know how Monte Carlo differs from EMV. EMV is going to give you one expected value, probability times impact. Monte Carlo gives us a distribution of outcomes. EMV is simpler overall. Monte Carlo is more powerful. Both are going to be tested on the PMP and the RMP, more on the RMP side, so know when you're going to use each one. And number 5, understand merge biasness. The sum of all your most likely estimates underestimates the true expected duration that you're going to use. And it's all because uncertainty paths compound over time. That right there is your Monte Carlo exam checklist of what you need to know for the exam. Triangular distribution, how to read the chart, when to use it, EMV versus Monte Carlo, and merge biasness. You now know all 5 to help you up for success there. Monte Carlo is not math for mathematicians. It is a forecasting tool for project managers. 3-point estimates in, probability distribution out. Again, if you want to check out this tool, riskreadypm.com, go check it out, play with it. It is purely a tool for educational purposes, but you can still see how it would work out there. And if you want to go deeper in my PMI RMP exam prep material, then go to 44riskpm.com. Check out the RMP section within there. And also, don't forget to subscribe if this video helped you out when it came to Monte Carlo and just understanding risk management in general. Stay motivated, stay dedicated. 44 Risk PM out.